task? The task states that we have a glass jar covered with cellophane and tightly folded paper tube with length of 4 to 5 centimeters inserted hermetically into the jar through a cellophane cover. The tube should be oriented horizontally and should be burned from one side. We should explore this phenomena. Well, our first question would be, or first we would like to see some explanation of the paper burning. There was some mention of pyrolysis inside the theory of the presenting team, but no further explanation was provided. They tried to determine the smoke trajectory, although the air drag and airflows were taken into account, although maybe not really correctly like they should be. And there was some proof that the jar is needed for stabilization of the stream, although we aren't exactly sure when or where should it be laminar or turbulent, or where should be the interface between these two phases of the stream. And it wasn't not really explained how or where or when should the constant temperature work. Next to the experiment, theory, we have absolutely no quantitative prediction, and we have no idea what is really the composition of the stream, which should be a part of a presentation which clearly states that we should explore some phenomena to the experiment. Actually, we've seen plenty of experiments with changed tubes of different parameters, and we experimentally found limits of the tube size. Although we have a problem with it too, we would like to discuss it further in the discussion. And they also changed number of layers, which is again a class, but still we are not sure why does it work like that. And they measured somehow the smoke velocity, although we have a feeling that it's a really incorrect way of measuring these speeds. In general, this task actually brought some very, very basic insight, although it has many contradictions and many uncertain statements which we would like to correct in the discussion. Thank you. I would like to transfer the rest of my time. Please. Okay, firstly, maybe we should start from the task itself. It's actually really very specific task. They want some very specific parameters to be achieved. Do you know why should we cover the tube with cellophane, or why should we use the tube of the exact length, or any of the other parameters which were mentioned in the task?
Okay, as a matter of fact, there is no difference between hermetically closed jar and not hermetical, because the character of the smoke stream will be the same. It will be, it can't somehow influence on the velocities of our smoke stream, and it can't influence.
Okay, so do you find it strange that it is specified that specifically in the task and you don't see any difference between it? Could you show us a video of the paper burning without the hermetical closure and with it? You can talk about other of these parameters in the time.
About the length of the tube, as I told, there were almost no difference. Only difference was in time of observation of the phenomenon.
Okay, so here we see it without any closure, and could you show us it without or with the closure? Sorry.
As I told, the only difference was in stabilization of the stream, because when we
why
have
do you think it's like that?
Because inside our jar we have less airflow that can occur when our tube is in the open air.
Okay, so you told that there's some pressure equalization, or?
We think that pressure doesn't change in time because.
And why shouldn't it change in time? Because if you look, there's some matter flowing inside, and if you tell us that there's no pressure equalization, the pressure should be higher inside the jar itself. Why is it?
You see, as a matter of fact, there are some points about why pressure is constant. If the pressure is not constant during our experiment,
So when is the pressure constant? If you don't make anything, or
No, the pressure remains constant during the phenomena. It is because
so there needs to be some pressure equalization between the hermetically closed jar and the surrounding. Or
I think that pressures is equal.
So there needs to be some equalization because there's matter flowing inside. So
I explain.
where does the okay
I
fine.
explain.
Actually, that's something I want
You
to
see
do.
that our cellophane is
Yes.
very thin and it can deformate to predict changing of our pressure.
And did you see any change of or deformation of the cellophane?
We don't see any deformation. As you see, our volume was quite large. And another thing, if we have changes of the pressure, we took this very, very small volume of the jar and took covered it with it has a tape.
Yes.
As you see, it is deformated very hard.
Okay,
And
so
we took a very long tube. The length of the tube was about 10 centimeters. And if the pressure changed,
So
the
you're
small
stating-
strips must stop and
Okay.
must flow into the jar. But
Okay, so
as you
your
can-
statement is that the pressure changes through the deformation of the cellophane itself.
I don't think that pressure is changing at all.
Very well, even if there's matter flowing inside. Okay.
I think that.
Well, okay, could we go to the slide number 7, please?
Okay.
Okay, there was some picture showing us something about temperatures. Well, why should we do the temperature constant again?
Okay. I mentioned that in matter of fact there is some distribution of temperature, but for simplification of our theoretical model, we take into account that all our volume of the snow that is in our tube have the same temperature in the same point, but this temperature have changes in time.
Okay.
It's only for simplification because it's very difficult to
Okay, could
take
you
into
go one
account.
slide back, or 2 slides back, actually? Okay,
You
this
about,
slide, yeah.
this
Okay, so is this the same, the part of the same model you were mentioning? Because I see that you stated that the temperature isn't constant.
Yeah, but it is I told about this temperature distribution for formation of the snow, but for movement of our snow stream, we take it's
And does the smoke burn?
of course
It does burn.
yeah, of course.
So if there's constant temperature in the whole tube, it should burn in any place of the tube, shouldn't it?
The temperature inside the tube is not the same as the temperature of burning.
Okay, but shouldn't the temperature be distributed somehow
Uh,
equally, as you say, close to the temperature of the
Okay,
flame?
I may explain that first we have some temperature inside the tube, we have some temperature outside the tube, and we have temperature of burn. These three
Those are
temperatures.
totally different temperatures.
Yeah, of course it's different.
And could you tell us at what temperature does the smoke really burn?
The paper burns at the temperature of about 250 degrees, something
And
like that.
is it the temperature lower than the temperature of the flame? Like, isn't it? Or-
Yeah,
Oh, okay.
it is lower.
Okay, so could we go to the slide number 9 and talk about the air drag itself? Because my question is, shouldn't the air drag actually somehow inhibit the motion on the horizontal axis and cause the flow to simply fall down on a straight line?
Of course it should, but we have not only air drag.
Yes, what have you more?
We have, you see, the tube that inserted into our jar has a temperature larger than temperature of our outside air
Okay.
because of heated gases that come from it and because of thermal conductivity of
Yeah,
paper,
of
of
course.
course.
Okay.
That's why conventional why it's curved our trajectory.
Very well. Okay, and this brings us to the laminar or turbulent flow. How does the flow itself look inside the tube? Is it a laminar flow inside the whole volume of the tube, or is does the smoke really fill the whole of the tube, or doesn't it?
You mean the motion in the tube, not
Yes.
only outside?
If you could show us some video, for example.
We can't. You see, we can't look inside the tube because
Why can't you?
you see, it's very difficult because
Paper isn't transparent.
our paper is not a transparent thing, and
Well, okay, these
when
are
we-
technicalities. Do you have any idea how does the smoke flow really look inside the tube?
You see, we made experiment for, as I told, for diameter 1 centimeter.
Yes,
when
and?
there are
And what were the results?
convection.
Okay, but
and
the
so-
convection
so-
and turbulency were outside of the tube. Do you have any idea how does the flow look inside of the tube?
inside of the tube, at the beginning, I think that motion of the flow of the
But does
Flow
does the
is
stream
turbulent.
really fill the whole volume of the tube, or does it fill only a part of the tube, the flow itself?
but the flow fill only part of the tube.
Okay, so there's a space through which oxygen can flow. Why should there be no pressure equalization or airflow inside the tube?
You think you see smoke fill only part of the tube because of the convection that I can't really say which part of the tube it fills, and I don't think that there are any airflow.
But why do you
from
think
the
it's
jar.
really like that? It's an assumption you have based on not any proof.
You see, when we have a very thin, very little in a diameter, the smoke stream fill almost all our tube. That's why I think that there is no airflow from the jar to outside.
Very well. Okay, could you go to the slide number 19?
Okay.
Okay, we see some graph where we see a dependence of speed on number of layers. I can clearly see that it would probably go to the zero somewhere around 9 layers. Why should it be like that?
We don't go into
Well, but
because
the
it
speed
is,
looks like it.
it is hyperbolic approximation and it moves to the zero.
So it shouldn't reach zero, it should simply
Yeah,
go near. Oh,
because
okay.
we can't do a very thing.
And could you tell us why should the speed really decrease with the increasing number of layers?
Okay, I can explain. You see, when we increase in number of layers, the inner layers burns slower because there are not enough oxygen to burn it, and that's why with increasing of burning velocity.
Okay,
the
simply you're saying that there's more matter, so there is not more oxygen needed to burn and doesn't work.
Yeah.
Okay. Okay. So and lastly, you mentioned that you have some theory which you're trying to prove. Do you have any quantitative theory, any equation which could prove that your theory really works?
I told when I talked about theory that we can't really.
But you had
estimate-
some equations in the presentation.
I have equation, but
And do they work?
I told that only form of our dependence can be used, and as you see,
Oh, so that's why the constant were there. You don't know what they should be really in the real world. Or,
What do you mean?
well, you had some equation with constants. You simply called, I don't know what constant they were. And can you use this equation if I gave you the parameters of the tube, or doesn't this equation have any predictable value for us?
You see, there are parameters, almost parameters of the tube parameters. There are pressure.
So it doesn't have any predictable value for us.
But you see, there are some parameters that mass of gas that form per unit time, and we can't, in theory, predict which mass of gas.
So you can
Okay,
predict.
yeah.
We can't.
Okay,
Okay,
thank you for the
thank you.
remark. Yes, thank you for the discussion.
Thank you.
So can you give me the very reason, in one sentence, why the smoke is flowing inside the jar? Just one sentence.
Air that we have everywhere expand because of burning, and that's why it expands everywhere.
Just one sentence is that. Thank you. And how about you?
Actually, it should flow inside the jar because of the temperature differences inside the tube itself.
Okay. Speaking of temperature difference, you consider it as constant or varying?
I told that in fact there is some temperature distribution, but in our model we consider that temperature is constant.
So it's constant. So why is the smoke at the floor? Why is the smoke at the floor? Because if the temperature is constant, smoke is warm, why is it flowing?
You see this temperature that we consider constant, we take this temperature constant.
Why is it flowing? Just the reason.
I explain you. We consider the temperature is changing in time.
Okay.
And
But the smoke is flowing instantaneously, you said. Why is it flowing? Just one sentence.
It moves down because density of the smoke.
Okay, thank you. How about pressure?
The pressure is constant.
Okay. In video on slide 20 and 24, we can see that there's non-laminar behavior of the stream. Do you have any explanation why? It's inside the jar.
Inside?
Yes, it's inside. At the very end of the video, we can see like something like a falling tunnel. Do you have
It is,
explanation?
at the very beginning of our phenomenon, where the first stream appears.
No, it's at the very end of the video where it's already been streaming. Just this simple explanation.
The smoke can't be cooled enough to move down. That's why
No, there's
convection
okay.
starts.
But you said it's flowing laminarly.
It's a beginning, yes. When the length
Why is it not flowing in like that in the end?
because the length of the tube is small and the temperature of the smoke is large, and that's why
Okay.
it moves with easier with hot air streams.
What would you think if the tube had a very small diameter and very many layers? What would happen? Just some short prediction.
Actually, it wouldn't burn. The smoke wouldn't flow out.
Okay. And if it were just as much that the smoke were flowing out?
I think it would flow.
Okay. Yes, we're out of time.